Okay, welcome to Math 60, the lecture for section 2.7. This is all about inequalities. Okay, remember we've done these a little bit, but now we're going to put them into equations and stuff. So, less than, greater than, you know those. Remember, we also sometimes did it with the teeth, and you're welcome to do it. So you've got this nasty looking alligator. Okay. Less than or equal to and greater than or equal to. So linear inequalities in one variable have to have a variable. That's really all that says. Now, when it comes to graphing linear inequalities, we're going to use certain symbols to indicate the beginning or ending of our inequality. Now, this kind of parenthesis, this is called an open parenthesis, and it's opening upwards, because that's the one that opens or starts a set of parentheses. So this is the open parenthesis. And this is indicating greater than 5. Okay, but no equal to. If I was going to say x is less than or equal to -2, I would have -2 down here. And I would use a square bracket. That's what we use for if it includes the equal to. Okay, so graph x is less than or equal to 2. Okay, so we have 0, 1, 2. All right, we're going with x is less than, and then it does have the equal to, so we use a square bracket. This indicates this direction. All right, graph y is greater than 4. So I'll put my 0 here. 1, 2, 3, 4, 4. And it's a parenthesis because there's no equal to. It's greater than, so it's opening upwards. And my direction. Y is greater than or equal to -2. I have 0, -1, -2. And this includes the equal to. Y is greater than, so it opens upwards, and it's the square bracket. All right, interval notation. Basically, this is done just like you're working on a number line. So, for example, this would be 5 with the open parenthesis, and it's going to infinity, so it includes that section. If I had something like this, 0, we're going to do a 3, I'm going to put a solid bracket. This is going from -infinity to 3 with the square bracket. Okay, infinity and -infinity, they will always use the open parenthesis because you can never actually equal infinity. So it's always the parenthesis. All right, here you see this. These are our different kinds of notations from our graph, our interval notation. We also have a set builder notation. We're going to be mostly using interval and graph. So if x is greater than a, it's from a to infinity. This is x such that x is greater than a. That's how you read that. X such that x is greater than or equal to a. All right, here because it's got an equal to portion, it has a square bracket. Notice infinity still has parentheses. Negative infinity, both have parentheses. This one would have the equal to part. This one would have no equal to part. There we go. It's pretty straightforward and actually quite visual. Okay, express x is greater than or equal to 25 in interval notation. So if x is greater than, then 25 is the bottom, and I'm going to infinity. Now there's an equal to portion, so I put a square bracket there. Infinity always has a parenthesis. Express x is less than 6. Okay, now I'm going from -infinity to 6. No equal to, so I have a parenthesis on both sides because infinity always has a parenthesis. Okay, now we're going to fill in our little chart. We're first going to graph. We have 0, -1, -2, 1, 2, 3, 4, and 5. Okay, so notice the parenthesis on -2 and the square bracket on 5. So what this means is that -2 is the bottom, x is in the middle, and I could be equal to the 5 at the top. There we go. Okay, x is less than 3. So if we were going to graph this, 0, 1, 2, 3, we put our 3, no equal to, so we just put the open parenthesis. So this is going to go from -infinity, because it's less than, all the way up to 3 with a parenthesis on both, because infinity always has parentheses. Here we've got a parenthesis opening, so we know that x is greater than, not equal to because it's not a square bracket, -8. So we're going greater than, so we're going to start with the -8 and we go all the way to infinity. Infinity always has a parenthesis. This one started with parenthesis as well. Okay, that's really all there is to it. It's just take some practice to get the hang of it. All right, properties of inequalities. You can add or subtract as long as you do it to both sides, you're cool. Now, multiplication is a problem. You can do positive without any problem, but you have to be aware when you've got a negative. If C is negative, notice my symbol flips for both of these. Symbol flips if you multiply or divide by a negative number. Okay? All right. Other than the extra property, and the sets to solving an inequality are the same as linear equations. So, solving the following inequality. So we do like we've always been doing. We add 5 to both sides. We get x is greater than or equal to 7. They want us to graph our answer. Got our number line. We've got a 7. X is greater than 7. So I'm going to put my 0 way down here. 1, 2, 3, 4, 5, 6, 7. All right, equal to also, so I have a bracket, and I'm greater than. You don't have to include an arrow. That's fine. All right, I add 8 to both sides, and then subtract the 2x. I get x less than 19. Then 2 x's, and then the 2 8's cross out. Okay, so graph this. So we're going to put our 0 down here. What we're going to do now is I'm just going to count up by 5s. So I know that I have to be, x is less than, so I need a little, and that's 19. Okay, that's all I need. I'm going downwards. But the direction I open this parenthesis should tell you that. All right, I add 1/3. Now, I'm going to need a common denominator to add these two. So if I multiply 1/3 by 2 over 2, I get 2/6. So x is greater than or equal to, well, 5 is 7/6. There we go. So 7, that doesn't really look like 6/6. So it's just over 1. So I have 0, I have 1. Just filling out my little number line. All right, now I'm greater than or equal to 7/6 is just a bit more. 6/6 would be 1. And does have an equal to, so it's square brackets, and it's greater than, so I open upwards. Okay. I'm going to add the 13y, so I get a positive. Therefore, I'm going to subtract the 17. So negative 12 and a positive 13 is 1, so I have y greater than 20 minus 17 is 3. All right. No parenthesis, a parenthesis, no square bracket because there's no equal to. Y is greater than, so it's opening upwards. And there we go. All right, now I'm multiplying by a negative. Woo, 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 woo. That's my alarm bell. It's not a great one, but there you go. Woo, woo. Okay. Negative means I flip the sign. If I have to multiply or divide. So here I have to divide by negative 7, which means that x, flip my sign, is less than 3. I know, kind of silly. 0, 1, 2, 3. So x is less than 3, no equal to portion, and there we go. All right. Oh, another negative. Woo, woo, woo. Okay, we're enough woo, woo. Okay, so we're going to divide by negative 2. Well, I'm really multiplying by a negative 1/2, so I'm going to do that here, because fractions are easier to multiply. The negative 2's cross off. I have y. It was negative, so I have to flip it to greater than or equal to. And I multiply straight across, I get 1 over 4. So, 0, 1. So negative 1/4 is pretty close. And y is greater than or equal to, so I go like that. And you can label the spot it's crossing if you wish. There we go. All right, now I add 4. 8x is greater than 16. I divide by 8. It's not negative, so I can do that without any problem. X is greater than 2. 0, 1, 2. X is greater than, so I open upwards with an open parenthesis because there is no equal to. Okay. 5 minus 3x is greater than or equal to 20. So I'm going to subtract the 5. I have negative 3x is greater than or equal to 15. Now I'm going to divide by negative 3, so I have to flip my sign. So x is less than or equal to negative 5. You can always check these by plugging in a number within the range. So if x is less than negative 5, let's do negative 6. So if I plug in negative 6, I get a positive 18. 5 plus 18 is indeed greater than 20. There we go. All right, so we'll put our 0 way up here. 1, 2, 3, 4, 5. Negative 5, and it's possibly less equal to, so x is less than or equal to, so I open it in the negative direction. Sorry. 9. Distribute 4x plus 4 plus 2, greater than or equal to 3x plus 6. All right, this is 6. So 3x, I'm going to subtract the 3x, and I'm going to subtract 6. So I get 4x minus 3x is x, and 6 minus 6 is 0. So that's still a perfectly good equation. So we have 0, x is greater than or equal to, so we put a square bracket, and there we go. Pretty straightforward. All right, I'm going to distribute the 3 in. 3x minus 5 is less than 3x minus 6. Well, now, what's going to happen when I subtract 3x from both sides? Well, my x's go away. That's a problem. I end up with negative 5 less than negative 6. Okay, is this true? Is negative 5 less than negative 6? If I have a 0, 1, 2, 3, 4, 5. I have negative 5, negative 6. Is negative 6 less? No, it comes first. It's smaller. Yes, it's less. Negative 6 is less. Negative 5 is not. So this is never ever true, so it's no solution. All right, let's look at this one. Oh, look, I have the same problem. I'm going to lose my x's. Now I have 4 is less than 10. Is that true? Well, yes, of course it is. And no matter what x is, it's still going to be true. So it's always true. So this is infinite solutions. Okay, all numbers. Okay, and we are done.